Okay, let's give this team a nice warm welcome. This is Team Charly. All right, so your team members are
Victor,
Victor,
Isar,
Izar,
Ivan.
and Ivan. Cool. All right.
ESS 55 class at Chabot College. And this is our team project, CNC drawing machine. Well,
And the purpose for this project is to build an easy and budget-friendly Arduino-based CNC drawing machine using low-cost and 3D print materials.
And the hypothesis is we use the Dribble as the open source software, which enables the Arduino to become a CNC controller, and we use the G code as language, which tells the machine to do something, to draw it basically.
Mm-hmm.
And we use Inkscape as the program to help create the design.
Nice.
so right here we have a list of the materials that we use. The main components: Arduino Uno, CNC shield, step motors, step motor drivers, and a Inkscape server. Those are the main components.
Nice.
Diagram.
So right here's a diagram of the CNC shield. Right here are the driver motors, step driver motors. So they are connected.
Yeah. Here's all the materials that we use to make our CNC drawing machine. With the Arduino, we use the glue gun to put in, or make our case for our
Mhm.
CNC shield. That was fun. Yeah.
Wow, heat sinks too, huh?
Yep. Very nice.
Stepper motor driver.
Nice.
Yep.
Assembly
And
process.
assembly and process, yes.
Debugging and troubleshooting.
Very nice.
So after initial analysis, we concluded that making this do-it-yourself project is fun. It's entertaining. Now kids make drawings, signs, pretty much almost anything.
Mm.
And yeah, so it just made us wanted to see how far we could go with it.
The application, it can be used in a variety of fields. Since we can add food-grade color to it, we can print edible pictograms to make food more attractive, like a cake with a special picture for an anniversary, a graduation party personalized with a custom photo on top of a cake. Also can be used as a calligraphy device to make custom design templates for diplomas, degrees, certificates, etc.
Nice.
Yep. And so we're excited right here. Everything we use to help make the machine.
Mm-hmm.
These videos are actually very helpful to.
This is the live links. We can go click in it. And
Try one.
Take us direct to YouTube.
Ah,
So
okay.
this is our best friend.
Nice.
And this is us.
Nice, 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 nice. Well, you're going to demonstrate this working now, yes?
Yes, sir.
It is working.
Okay, so we will follow you over.
All right. So first, we go to the website. We're using chili pepper,
Mm-hmm.
like that.
No, come here. So, come here. You want to see this?
Now we need to connect the Arduino Uno to the web page.
Mm-hmm.
We're gonna use a Johnson server. Right here. Use a download and execute it.
To let me know.
We recognize the Arduino Uno,
Mhm.
COM5. We refresh server, and right here we have the Arduino.
Let's see.
Select Gerbil, select the Arduino. Now we unlock the alarm, like that. Now we need to send the Arduino to home. For that, we click on access. All right, so that's home.
Mm-hmm.
We set to 0, and now we start drawing, hopefully.
Are we making the other one?
As long as the ink isn't dry.
Yeah, this is actually our first one that we made.
Doesn't count. Don't count now.
Yeah, that could be a photocopy for all we know. We want to see the real deal.
So if this one broke, you fell.
You can feel the love in the room, eh, Ivan? If it breaks, you fail.
Oh,
So that's it.
So how are things working to lift the pen up? Can you describe that?
So we have one motor right here that controls this,
A servo.
to raise and lower the pen.
Very clever. So one motor pulls the pulley
Mm-hmm.
and it lifts the pen up at the critical moment.
Yeah, right here.
Yes.
You have the 2 motors.
And
right
the
here,
other
with
motors
the X's and
provide the X and Y axis
mhm.
for moving.
Right here we have the Arduino
There's
With
the
CNC
Arduino
shield.
with the CNC shield. Very nice.
Yeah, step motor drivers right here too.
Step motor drivers. Very nice.
The motors are connected right here
Mm-hmm.
to the drivers.
Very nice. So can you describe the 3D printed parts?
Very long process and a lot of trial and fail. So all the work parts, but the paper itself is 3D printed. These 2 mounts for the main rail. This guy here,
Yes.
it has 2 bearings inside, 2 linear bearings that hold the motor, and 2 micro switches, also for the limit switches for the axis.
Mm-hmm.
This is 3D printed, which holds the long transfer belt that drives in and out,
Yes.
along with this servo motor.
Mm-hmm.
As you can tell, this guy here.
I see that.
So this one on the front is a 3-piece, 4-piece
Mhm.
all put together. It's the same. We have idle pulleys on this guy
Mm-hmm.
and a linear bearing with a 6 mil shaft integrated to it for counterweight as well. So when the stepper motor pulls out, lift up the pen so it can position in a different place.
Yes.
Releases the tension on the belt and drops down so the pen can start drawing in a different spot.
Mm-hmm.
We can change the pen, we can change the color, we can do different drawings.
Nice. So you also mentioned in terms of a practical application, if you use edible ink, then you could be painting some image that can be used on food products, yeah?
Yes.
So that's how they get photos and other images on birthday
Cakes.
cakes.
Mm-hmm.
It's something similar to this, yes?
Can you do it one day too?
My law.
I want some cake on Wednesday.
Oh, this is working beautifully, guys.
Thank you.
Very, very nice. I'm going to come in a little closer. Look at that. Got some name action going.
I like how I draw backward.
Yeah.
Yes.
It's left-handed.
Yeah.
So for whatever was left-handed, so
Backward.
it goes back.
Yeah, very smooth how the bearings allow for the XY axis to work. I love how the servo motors are connected to the type of gears that you're using. These belts are have teeth in them, so they can be very precisely controlled by your pulley mechanism.
And there was a lot of fairing trials.
Mm-hmm, yes.
We broke a couple parts, we had to remake them.
A lot of sanding.
Yes.
the sanding, drilling, it doesn't fit. We had to redo it again.
Yes. Well, a lot of time and effort for sure went into this, as you can see, for the mechanism to work so nicely, securing it onto the platform and finding the appropriate mounting distances and everything. Took a lot of planning and I'm sure a lot of troubleshooting, trial and error. So this is looking very nicely. Let's just finish spelling out something. Look at that. Very, very nice. Okay, fantastic. Well, let's give this team a round of applause. Very, very well done. Team members, stand together. And for a moment, if you would, pull off your mask so we can see your smiling faces and record this moment for a happy, successful conclusion. Excellent. Good job, guys.
Thank you.
Thank you, thank you.